Bismillah ar-Rahman ar-Rahim. We'll continue. Now we'll start the old exams questions related to this section. Okay. He said if the general solution of this is this one, so what we need to do? We need to find the eigenvalues and eigenvectors. Okay. For the eigenvalues, I can do it A minus lambda I equal to 0 and find lambda 1, lambda 2. This is one way. Another easier way. I notice here, this is lambda 1. And I know the trace of A equal lambda 1 plus lambda 2. This is my lambda 2. What is the trace of A? The sum of the diagonal elements, which is 4 minus 1 is equal to 3. Lambda 2 is minus 2 plus lambda 1 is minus 2 plus lambda 2. So lambda 2 equals what? 5. So I get lambda 1 and lambda 2 without solving. So this is 5 without doing this calculation. Yeah, sometimes that will help. Okay, now we'll find the eigenvectors, this and this. Notice here my K1 is 1, here my K2 is 1. So I'll have that in my mind. Now we say for lambda equal minus 2, lambda 1, we need to find the A. Let be 1, K1, K2. So I have what? Let me do it here. A plus 2I times B1, which is what? 6, 2, 3 minus 1 plus 2, 1 times K1, K2 equals 0, 0. So that implies 6K1 plus 2K2 equals 0. 3K1 plus K2 equals 0. So I have K2 is minus 3K1. And they want K1 to be 1, because as you know, the eigenvectors, we have infinitely many. So I need K1 to be 1. I get K2 equal minus 3. So A, this is minus 3. So this is minus 3. Okay. Now let me do for the other lambda 2 equal 5. What I will have? I let V2 to be K1, K2. Some of the things I wrote here, maybe you don't need to write it when you, because I'm explaining it. Huh? When you do the exam, sometimes maybe you don't need to write some, like letting this, but I'm trying to make it a complete answer. Or 4 minus, no, that's minus 1, 2, 3, minus 1, minus 6, K1, K2 equals 0, 0. So what I have? Minus K1 plus 2K2 equals 0. 3K1 minus 6K2 equals 0. Very clear. Multiply the first one minus 3. You get the second one. So I have K1 is equal to K2. So now I want K2 to be 1. Let K2 equal 1. I get K1 equal 2. So I have 1 minus 3. So A minus 3. Here I have 2, 1. So B is 2. So this is 2. So I have minus 3 plus 7, which is 4. So this is my answer. Okay. Yeah, the solution of this at t equal by is, yeah, I need to do this from A minus lambda I equal, since I have t equal by, so it's very clear I have non-real eigenvalues. I don't have any by here except the power. Okay, so let us do it. 4 minus by. This is minus 3, 3. 4 minus lambda, not by. 4 minus lambda. That will be what? Lambda square minus 8 lambda plus 16 plus 9 plus 25 equals 0. So lambda will be what? 8 plus or minus square root b square which is 64, minus 4 times 225, which is 100 over 2. That give me what? Yeah, this is 6, so I have 4 plus or minus 3i. So now I work out just the positive one. So you get what? Let V1, K1, K2, you get A minus lambda 1i V1 equals, let's write it here, 4 minus 3i, huh? And minus 3, and this is 3 minus 3. I think we did it before. Okay, K2 equals 0, 0. Okay, so I have what? Minus 3i K1 minus 3K2 equals 0, and 3K1 minus 3i K2 equals 0. Multiply by I, the first equation, you get the second. Yeah, very clear. So I have, here I have K1 equal I K2. So I let K2 equal 1. That implies K1 equal I. So I have V1 will be what? Will be I and 1, which I can write it 0, 1 plus 1, 0 I. This is B1 and this is B2. Yeah, let me try to write the solution. X1 will be B1 cosine, what is alpha? Oh, what is beta? Cosine 3t. Okay. Minus 1, 0, which is B2 sine 3t times e to the power 40. X2 will be 1, 0 cosine 3t plus 0, 1 sine 3t a40. Yeah, my capital X, general solution, this plus this. Okay, now I need it as 0, so I have X at 0 will be what? Yeah, let me do it in steps. C1, now substitute 0 here, cosine 0 is 1, sine 0 is 0, gone, and e to the power 0 is 1. I need to find C1 and C2. So I have cosine, that would be 0 and 1. X1 at 0 will be what? Cosine 0 is 0, is 1, huh? And e to the power 0 is 1. That's what I have. Plus C2 times what? Now I put 0 here. Cosine 0 is 1, sine 0 is 0, e to the power 0 is 1. So I have 1, 0. That should be equal to 1 and 2. Actually, before that, let me do this. That will be C2, C1. That is 1 and 2. So C2 equal 1 and C1 equal 2. So my answer, X will be 2x1 plus x2. Now I want X at pi. Yeah, be careful now with the calculation. I have 2 times x1 at pi. X1 at pi, I have cosine 3 pi, which is minus 1. So that will be 0 and minus 1. Okay, that will be 0 and minus 1. Sine 3 pi is 0, e to the power 4 pi. That will be x1 at pi plus x2 at pi cosine 3 pi. That will be negative 1, 0. Sine 3 pi is 0, e to the power 4 pi. So that give me what? Minus 1, minus 2, e to the power 4 pi. What is this one? Yeah. Yeah, you notice they are quicker than what we did when we solved when we do the full problem. Now he gave you something, he wants you to do the rest. Yeah. Here, I need to do a minus lambda I equals 0 to find lambda 1, lambda 2, and lambda 3, which will take a long time. However, I know this is lambda 1, so lambda 1 equals 3, and lambda 2 equal lambda, and lambda 3, this is e to the power 0, lambda 3 is 0. So you have the trace of A, which is the sum of the diagonals, the sum of this angle, of these values, it will be -1. That should equal 3 plus lambda plus 0. So my lambda will be what? Take 3 to the other side, it will be -4. Are we done? No, not yet. By the way, he needs only A and B. So he wants me to do eigenvectors only for lambda equals 3. I don't need the rest. Okay. Yeah, this is what I mean. Sometimes in the old exams, they will not ask you to do full solution. He wants you to do something, some of it. Okay. So now for lambda 1, we call it equal to 3. I let V1, K1, K2, K3, and I need to solve A minus 3I V1, and that is what? Yeah, A minus 3, that will be -2, 2, 1, 6 minus 4, 0. They have -1, -2, and the last one, no, sorry, yeah. I need to add 3, sorry. I need to add 3. It is A minus 3I. Yeah, that's correct. 1 minus 3 is -2. This is -4. -1 minus 3, that also will be -4. Yes. K1, K2, K3 equal 0, 0, 0. Okay. To solve this system, I can do Gaussian elimination. What I will do, I'll make this row the first one. So I make it, I multiply by minus. We did that, something like this before. And I have 6 minus 4, 0, 0, -2, 2, 1, 0. So multiply by -6 and add, that will be 0. By -6 and add, by -6 and add, that will be -16. I think we did something before like this. -6, that will be -24, 0. Now by 2 and add, 2 and add, that will be 6. 2 and add, that will be 9. Yeah, we did the same problem before. No problem. Yeah, let me continue. 1, 2, 4. This is 0. Divide by -8. That will be 2, 3, 0. Divide by 3. 2, 3, 0. So we have 1, 2, 4, 0, 0, 2, 3, 0, 0, 0, 0, 0. I want K3 to be -2. This is what I have in my mind. Okay. So from this, I have 2K2 plus 3K3 equal 0. So I have K2 equal -3 over 2K3. Okay. So I need K3 to be -3, -2, I mean. So K2 will be 3. Okay. I need K3 to be -2. I choose -2. I get 6. No. 3. Yeah, correct. Yeah. I plug these two here. So I have K1 equal what? -2K2 -4K3. And this is what? -6. Okay. And +8, which give me 2. So this is K1, 2. And K2, we say it's what? 3. Yeah. And lambda is -4. So I have 2 times 3 times -4, which is -24. And that will be the answer. Okay. The solution of this, yeah, it seems to me that I will have not real eigenvalues. let me do the calculation. 1 minus lambda minus 2, 2, 1 minus lambda. That will be lambda square minus 2 lambda plus 5. So lambda will be 2 plus or minus square root 4 minus 20 over 2. So I have 1 plus or minus 2i. Okay, so alpha 1 beta equal 2. So I'll work out the eigenvectors for lambda equal 1 plus 2i. Since it's a procedure, I need the one with the plus. Yeah. So I have the system. Yeah, I let v1 k1 k2, and I get what? A minus lambda, call it lambda 1, minus lambda 1i times v1. That will be what? 1 minus 1 minus 2i. That is minus 2i minus 2, 2. 1 minus 1 minus 2i minus 2i again. Times k1, k2 equals 0, 0. So what I have minus 2i k1 minus 2k2 equals 0 and 2k1. Yeah, it should be the same equation. Yeah, multiply the first equation by I. I'm getting the second equation. So from here, I'm getting k1 equal I k2. So I let k2 equal 1. That implies k1 equal I. So v1 will be what? I and 1, which is 0, 1 plus 1, 0 I. That is b1 and that is b2. Yeah, we did something before. Okay, so x1, yeah, I need to be careful. It will be what? 0, 1 cosine 2t minus 1, 0, which is b2 sine 2t e to the power t. Oops. Yeah. x2 will be 1, 0 cosine 2t plus 0, 1 sine 2t e to the power t. Yeah, my alpha 1 plus or minus. Okay. Alpha is 1, beta is 2. Now my general solution, x will be c1 x1 plus c2 x2. Now we need the initial condition. I have x at 0 will be what? C1. Yeah. X1 at 0, it will be what? Cosine 0 is 1. That will be 0, 1. Sine 0 is 0. E to the power 0 is 1. Set. Plus C2. Now what I have? Cosine 0 is 1, 1, 0. Okay. That's it. 0 and e to the power 0 is 1. That is C2, C1. And that is equal 1, 2. So C1 equal 2 and C2 equal 1. So my solution will be x equal 2x1 plus x2. I want it at what? At pi over 4. That means x at pi over 4 will be what? 2 times 1. Now be careful. Yeah, pi over 4 I have. Okay. Yeah, pi over 4, then it will be cosine pi over 2. Cosine pi over 2 is 0, so I have 0. And I have here sine pi over 2 is 1, so I have minus 1 and 0. E to the power pi over 4 plus. Now the next one, cosine pi over 4, cosine 2 times pi over 4, it's cosine pi over 4, which is 0. So I'm concerned about the 0, 1. That will be 0, 1 e to the power pi over 4. So I'm getting what? minus 2 and 1 e to the power pi over 4. Yeah. Which is this one. By the way, this is opened. So this is the same thing, huh? Same. It happens in different, yeah, different terms. Okay. Now this one, he gave me, this is e to the power 0. So the eigenvalues 0, and lambda 2 is 1, lambda 3 is 2. But I need to find all the eigenvectors for all, because A is with the first eigenvalue, B with the second, and C is with the third. So I need to do all the 3 eigenvectors. Okay. Yeah. Yeah, since I have only one value there, I will tell you a trick to do. So now for lambda 1 equals 0, I will do A minus lambda 1I times V1. Let me say V1 is A, B, C, or K1, K2, something like this. So I have what? 2, 0, 0, 2 minus 2 minus 1 minus 2, 6, 3 times K1, K2, K3. That should be equal 0, 0, 0. One trick to do, you have this is 2 K1 equals 0. K1 equals 0. And you have 2K1 minus 2K2 minus K3 equals 0. And minus 2K1 plus 6K2 plus 3K3 equals 0. Okay, K1 here is 0. So this is 0. This is 0, gone. Now I have my K2 is minus 1. If K2 is minus 1, K2 is minus 1. So K3 will be 2, which is also here. Okay, this is minus 1. So I have minus 6 plus 6, 0. So this is my K3 without doing all the calculation. I need this vector where I have now K1 and K2. I can find K3. So A is 2. A is 2. Yeah, no need to do all of this calculation. For lambda 1 equal 1, for lambda 2, I mean, equal 1, what will be the equation? It will be 1, 0, 0, and you subtract 1, 2 minus 3 minus 1, minus 2, 6, 2, times K1, K2, K3, equals 0, 0, 0. So I have what? K1 equals 0. No need for K1. Minus 3K2 minus K3 equals 0. And 6K2 plus 2K3 equal 0. What he gave me? He gave me K1 equals 0, خلاص. And he gave me K3 is 3. He gave me K3 is 3. So I have minus 3K2 minus 3 equals 0. So K2 equal minus 1. Check here. Minus 6, 2 times 3, minus 6 plus 6 is 0, so it's okay. So K2 equal minus 1. This is minus 1, so B equal minus 1. Okay, now we'll do the last one. For lambda 3, which is 2. I have the system 0, 0, 0, 2, minus 4, minus 1, minus 2, 6, 1, times K1, K2, K3 equals 0, 0, 0. I can do the calculation, or I can do it right away. I say I have 2K1 minus 4K2 minus K3 equals 0. I have the second one. So I solve the other one for me to check. From here, I have K1 is C, so I have 2K1. K2 is 0, gone. K3 is minus 2. So K1 equal 1. Check from here. If this is 1, I have minus 2. This is 0. So plus 0 plus 2 equals 0. So that's correct. So C is 1. So I have +1, and the answer is 2. I need to solve everything since I know here I will substitute this is K2 and this is K3, I can get K1, and the same for the other ones. So sometimes you can do these tricks. Okay. Now what he said. Now he did not give me A, but he said A has an eigenvector associated to this eigenvalue. Then find the general solution. Be careful here. This eigenvalue is not the one usually we work with. Usually we should work with the other one, lambda bar, which is 4 plus 3i. If this is the eigenvectors, if V, let me write this, is an eigenvector for lambda, then V bar is an eigenvector for lambda bar. Actually, I'm looking for this because it's a procedure. So I need to find B1 and B2 according to the eigenvector for the one with the plus sign. Okay, so my work should be with V bar, which is 1 and minus I, and that is 1, 0 plus I, 0 minus 1. Okay, so B1, this is my B1, and this is my B2. Yeah. Then if I do this, what will be X1? X1 will be B1 cosine 3t minus 0 minus 1, 0 sine 3t e to the power 4t, which is what? Cosine 3t sine 3t e to the power 4t. Yeah. Okay. So this is wrong. This is wrong. These three, no, this one also wrong. You have cosine sine. Okay. Or, yeah, I don't know what is x2. We'll wait. We'll wait. Yeah. No need to rush it. Actually, everything is with minus here. Okay. So x2 will be what now? 0 minus 1 cosine 3t plus 1, 0 sine 3t e to the power 4t, which is what? Now this is sine 3t, is it? Yeah. And the one, it will be minus cosine 3t. Do you have that? I don't have this. But we know it's any linear combination also will give you the same answer. So minus sine with cosine. Yeah, this is e is minus 4t, so this is for sure. So this is the only answer. So it's also minus sine 3t if multiplied by any value is an eigenvector. It's, yeah, is a solution. Because you know, we write the solution C1x1 plus C2x2, like multiply this is by minus C2. By C2 is minus C2, so it will be a solution. So this is also correct. Yeah, this is I did before. Yeah. If you notice, we did many problems. Yeah, not like when I explained the topic. Huh? Now we're doing them quicker than before. Okay, let me continue. Now I have what? Yeah, it is 2, and I have 3 and 3. But 3 they have 2 eigenvectors, which is okay. So let me see what will happen. Now for lambda, actually this is 7.3, 7.6, but it's okay here. Lambda 1 equal 2. You have what? 2 minus 1 minus 1, 1, 0, minus 1, 1 minus 1, 0, times K1, K2, K3 equals 0, 0, 0. Now it's easy one. I have K1 equal K3 from here. It will be K1 minus K3 equals 0, and K1 equal K2 from here. Yeah, K1 minus K2 is equal to 0. So it means what? Everything are the same, huh? So K1 equal K2 equal K3. Now, if I plug it here, you'll get 0, huh? Let me do it in details. Yeah, actually, A should be 1, but I'm trying, yeah, I'm doing them quickly, or I do it in details. Minus K2 minus K3 equals 0. I have K1 minus K3 equals 0. I have K1 minus K2 equals 0. So from here, I have K3 equal K1, and from here, I have K2 equal K1. If you plug them here, I'm getting 2K1 minus K1 minus K1, so it will be satisfied always. So I let K1 equal 1 to get K2 equal 1 and K3 equal 1, which is 1, 1, 1, which is this one. Now for lambda 2 equal 3, what will happen? Have 1 minus 1 minus 1, 1 minus 1 minus 1, 1 minus 1 minus 1 times K1, K2, K3 equals 0, 0, 0. So I have only one, I have two free variables. I have only one equation where I have K1 will be K2 plus K3. Okay, now I have this. So I need K2 in this case. So K1 is 1, or this vector 1, B 0. I have K1 is 1, K2 is B, K3 is 0. So I have B equal 1. So B equal 1, A equal 1, B equal 1. This I need minus 2 plus 2. Be careful. The last one, I have 1, 0, 1, 0, C. What I have? I have K1, K2 plus K3. This is 1. This is 0. This is C. So C equal 1 also. C equal 1. What I need? A minus 2B plus 2C. That is 1 minus 2 plus 2, which is 1. Yeah. The eigenvalues of this matrix, it gave me the eigenvalues. Lambda 1 equals 0, lambda 2 equal 1, lambda 3 equal 2. Okay. If the general solution is this is my general solution. Okay. So I find the eigenvectors for 0, here for lambda 1 equals 0. Here for lambda 1 equal 1. He wants me to do it for lambda 2, lambda 3 equal 2. This will be my x3. So I'll work out only lambda 3 equal 2. Okay. So I have A minus lambda 3I times V3 equals 0. So it's minus 1, 1, 0. 1 minus 1, 0. 0, 1 minus 1 times K1, K2, K3 equals 0, 0, 0. What I get? Minus K1 plus K2 equals 0. K1 minus K2 equals 0, which is the same. K2 minus K3 equals 0. So from these two, I'm getting K1 equal K2. And from here, I'm getting K3 equal K2. So I let K2 equal 1. I'm getting K1 equal K3 equal 1. So my third solution will be 1, 1, 1, e to the power lambda, which is 2t. And that will be the answer. As I said, now the things will be quicker. Yeah, they will write the things away, which is do the calculation quicker. Now this one, but have different initial condition. It is the same as this one, which actually we did here. So it is my solution. This is my solution. Then I will do the initial condition accordingly instead of doing the calculation again. So you have x1 will be 0, 1, is it? Let me do it quickly, get it quickly. 0, 1 cosine 2t minus 1, 0 sine 2t e to the power, I forget, it's e to the power what? E to the power t. E to the power t. And x2, easy to do, that will be 1, 0 cosine 2t plus 0, 1 sine 2t e to the power t. What is the condition? X at 0, which is what? 0, this is 1, 0. Wait a minute. My general solution will be what? C1 x1 plus C2 x2. Now x at 0, that will be C1 times 1, 0. Cosine 0 is 1. With this one, 0, 1, sorry. This is x1, so that will be 0, 1. Cosine 0 is 1, sine 0 is 0, that's it. Plus C2. Now this is 1, 0. I have cosine 0 is 1, sine 0 is 0, gone. And that should equal 1, 1. So that implies C1 equals C2 equals 1. So what will be my solution? It will be C1 times x1. So I have it will be x1 plus x2. And that will be what? Minus sine 2t plus cosine 2t. Huh? Cosine 2t minus sine 2t. Huh? Yeah, the first element, that first row. If you want, I can do it in details. That's the first row is minus sine 2t. That will be cosine 2t. Yeah, everything times e to the power t, huh? Plus, now this one is cosine 2t, and this is sine 2t, all times e to the power t. So it will be cosine minus sine and sine plus cosine, which is this one. Yeah. If the general solution of this system is this, yeah. So I can find n easily using the trace, huh? The trace of A, which is this, equals 5, equal n plus 4. So n equal 1. N equal 1. I know n equal 1. Now we'll do the eigenvectors for these two eigenvalues without doing the calculation. Lambda 1 equal 1 to get the m. Huh? I have what? 1, 2, 1, 2 times k1, k2 equals 0, 0. So I have k1 plus 2k2 equals 0, same equation, or k1 minus 2k2. Okay. So very clear, to get k1 equal minus 2, I let k2 equal 1. So I'll get k1 equal minus 2. So this is 1, m is 1. Now for this one, well, lambda 2 equal 4. What I have? Minus 2, 2, 1, 3 minus 4, which is minus 1. K1, K2 equal 0, 0. So I have minus 2K1 plus 2K2 equal 0. And K1 minus K2 equals 0. Very clear, I have K1 equal K2. So this is will be 1. So K equal 1, so the total is 3. Yeah. Given that K is an eigenvector, that's correspond to the eigenvalue, the positive one. Okay. X0 equal this, and find x at y over 2. Okay. So what is the eigenvalues? Yeah, this is 5. This is alpha. And this is beta. Okay, this one I can rewrite 1, 1 plus I, oops, plus I 0 minus 2. So this is B1 and this is B2. Okay, so X1 will be 1, 1 cosine 2t minus 0 minus 2 sine 2t times e to the power 5t. x2, other way, 0 minus 2 cosine 2t plus 1 sine 2t e to the power 5t. Okay, my solution will be c1 x1 plus c2 x2. Now I need to check x at 0. X at 0. Let me see what will happen. Sine 0. So I have 1. Cosine 0 is 1. The rest are nothing. Times c1. Plus, this is c2 0 minus 2. That will be what? C1 and C1 minus 2 C2. And that should equal minus 2 and 8. So C1 equal minus 2 and C1 minus 2 C2 equal 8. This is minus 2. Take the other side. So C2 equal minus 5. Okay. So my solution will be what? C1, which is minus 2x1 minus 5x2. Okay, now we need to find x at pi over 2. At pi over 2, yes. That will be careful, minus 2. We do it like this. Okay. With pi over 2, I have cosine pi, which is minus 1 minus 1, minus 1 minus 1. Okay. Sine pi, which is 0, gone, times e to the power 5 pi over 2. Okay. Minus 5 times what? Cosine 2 pi, which is cosine pi, that will be 0, 2. That will be 0, 2. Okay. This is 0. Sine pi is 0. E to the power 5 pi over 2. So that gives me what? 2 minus 0, 2. 2 minus 10 minus 8. E to the power 5 pi over 2. Which is this one? Yeah. I think I will stop here. Yeah. I think we did a good number of problems. Yeah. So I'll stop here. I'll stop the recording. Now we did good number of old exams questions where I show you know in the old exam questions, the calculation they will be more smooth. I mean, it will be very, very smooth, and you don't need to do all the calculation. Thank you.